But the customer service, which is the human equivalent of this chatbot, is actually a communication flow based on a certain information that was used in our chatbots, like now in the past. When we call customer service regarding a subject, they are generally not attentive to the issue. There is a certain template given to them, and they respond to you accordingly. We still use this method today, and in the past, giving the customer information about the domain of the issue we are on is always one of the most important steps. The pattern matching method that I will show you later was already using this, and we still use it in GPT and other LLMs. Okay, early chatbots use pattern matching to classify text and produce a response. Author of the system needed to describe every pattern for which there's a response. A standard structure for this pattern is AI/ML, artificial intelligence markup language. In this method, words have no meaning except for their patterned existence within training data. While it used to be like this, the biggest deficiency in this chatbots is that the computer that communicates with people cannot communicate like a human. The biggest problem is that this has gradually disappeared in the present time, because now large language models can understand the meaning of the text of the sentence. Imagine that you are having a conversation with a person, and that this conversation is about a product. You are trying to find a solution to some problems, and even though neither of you as humans have much knowledge about the subject, we can do something very important, which we call reasoning, by making a cause and effect relationship in our mind. And this is a very important step of chatbot, because while people talk to any machine, they would like to get appropriate answers. So back then, this was a problem because they didn't have the models we have now. And usually this text generation task, which we call token generation, is now in a very good place with LLMs, especially in services such as chatbots. Since our biggest goal is to find solutions to people's problems and listen to them, this task becomes much more important, because people want to see that the other person listens to them, understands them, and can find a solution. And in recent years, companies have been trying to take this burden by minimizing manpower as much as possible and using chatbots. And lastly, we can see that there was a structure similar to the knowledge base we use now, and I'm going to explain the knowledge base more in depth in following slides. A system that answered the questions was created using these questions and answers written in AI/ML markup language. Of course, since we could not match sentences according to their meanings as we can now, the word-by-word categorization method was used. Since chatbots could not produce a sentence flexibly, freely according to the question, the words in the incoming question were compared with the words in the dataset. And whichever question had the highest rate, the answer to that question was returned. This process required that the dataset contain all variations of a conversation. The developer should have been able to think of all possible scenarios. And here's a sample. You see, do you know who Albert Einstein is? The robot's answer is that Albert Einstein was a German scientist. And as you can see, there is a pattern in our AI/ML saying who is Albert Einstein, and the answer is Albert Einstein was a German physicist. So even though the question was like, how old is Albert Einstein, probably the answer will be the same, saying that Albert Einstein was a German physicist, because the pattern was matched, like similarity has been made with Albert Einstein part, so the answer will be the same, even though the question was not about who is Albert Einstein, rather than how old is Albert Einstein. So this is not something we could do back then, but now we can do that. But even though back then people, an idea that people could have think something like chatbot before that, like human and machine interaction, I think it's a fascinating thing. And with that, we're going to talk about very first chatbots. And I'm going to talk about the three of them, that this three is the first three known chatbots. And after that, some couple of more chatbots has been made, but chatbots progress has been very slowly. So I'm just going to talk about the first three. And I think these first three are really, really good. And the very first chatbot was Eliza. And Eliza's mission was to act as a psychotherapist, returning the user utterances in a question form. Eliza used simple pattern matching and a template-based response mechanism. Its conversational ability was not good, but it was enough to confuse people at a time when they were not used to interacting with computers. Right now, this maybe the flow of the conversation with Eliza might not be, you might not be intrigued with the conversation with Eliza, but back then it wasn't even an idea. Like talking with computers was not even the main idea. So it was a really great step for back then. An improvement over Eliza was a chatbot with a personality named Perry. It also embodied a conversational strategy, and as such was a much more serious and advanced program than Eliza. It was described as Eliza with attitude. Perry was put to the test in the early 1970s using a version of the Turing test. Turing test means that distinguishing machine and human responses, actually. And it was described, a team of experienced psychiatrists analyzed conversation between real patients and computers running Perry. Meanwhile, another group of 33 psychiatrists review transcripts of these interactions. Both groups were then asked to distinguish between the patients who were human and those who were computer programs. The psychiatrists could only correctly identify the source 48% of the time. And this is a great deal. And back then, it was a big thing for this Turing test. The output of the Turing test is very, very extraordinary. And lastly, Alice relies on a straightforward pattern matching algorithm like Eliza and Perry, with its core intelligence built upon the artificial intelligence markup language, then allows the developers to define the foundational elements of the chatbot's knowledge. And I really recommend for you to read the paper of Eliza. That paper is really good. So if you'd like, I will send the link through chat. I recommend you to read it. And why we need chatbots? Customers want quick and easy help, even when it's busy. Like when bots handle the first chat, there's no waiting. You get instant support. And since chatbots are always available, they can help you 24/7, no matter where you are. So you can get help anytime, even if there are no human agents around. AI customer service bots keep track of how people react to every answer they give. As these bots gather in customer data, they'll keep analyzing it to offer better and more personalized responses. With the knowledge it accumulates, the chatbot learns which response works best in different situations. And as we just mentioned, chatbots did not have the conversational ability that we needed the most due to the way they were created. In such cases, the approach and style of answering the customer's questions are very important. In all chatbots, they could do this by providing answers, but then there was a great possibility that the answers will be single for a type of question and not answer the question directly and correctly. In addition to its low conversational skills, another disadvantage is its lack of ability to establish cause and effect reasoning. Think about possibilities and identify possibilities. But now you can make your chatbots smarter with LLMs that have started to be developed in recent years. I'm not saying that LLMs are like perfect, still can replace humans, but we're going to a very good place about that. And here comes the second part of the presentation. I'm going to explain LLM, and then we're going to talk about GPT and how did they train ChatGPT to how they fine-tune the GPT for people to communicate with the model more comfortably. So ChatGPT's answers will be enough for humans and wouldn't contain any toxic content. So let's start with LLMs. An LLM, large language model, I'm going to just say LM, is a computer program that has been trained with numerous examples to understand and interpret human language or other intricate data types. These models often undergo training using vast amounts of data collected from the internet, comprising thousands or even millions of gigabytes of text. However, the effectiveness of an LLM in learning natural language greatly depends on the quality of the samples used. Hence, the programmers may opt for a more carefully selected and curated dataset to enhance the learning process of an LLM. LLMs employ a form of machine learning known as deep learning to comprehend the relationships between characters, words, and sentences. Deep learning entails probabilistic analysis of unstructured data, allowing model to discern nuances in content autonomously without human intervention. Following initial training, LLMs undergo further refinement through the tuning process. This involves fine-tuning or prompt tuning the model to a specific task desired by the programmer. For instance, text may include interpreting question, generating responses, or translating text from one language to another. LLMs are versatile and can be trained to perform various tasks. One popular application is their use as generative AI, but provided with a prompt or ask a question, they can generate text as a response. For example, the publicly available LLM, ChatGPT, has the capability to produce essays, poems, and other textual content code based on user inputs. The biggest example of LLM is GPT. When GPT was first released, and I'm going to just give an example as a GPT as an example because I'm working on GPTs. So I'm going to walk you through GPT about with LLMs. And when GPT was first released, it was named the biggest model of that time because it was the first model trained with approximately 175 billion parameters. It was also trained with the 45 terabytes of legal internet data, as they say. It is said that GPT-4 has 1 trillion parameters, but there's no exact information about that. And GPT-3 is a model trained on the token generation task. So its purpose is to predict the next token in the sentence. GPT-3 can create anything that has language structure, which means it can answer questions, write essays, summarize long texts, translate languages, take memos, and even create computer code. ChatGPT is a service that uses GPT's parameters. Is this now an application that can be used by people who do not understand software and has entered our daily lives? I'm sure most of you always keep ChatGPT open in a tab in your daily life. It is perfect for performing small tasks effectively. But to achieve this, GPT implemented a different learning technique. So this technique called reinforcement learning from human feedback. So this technique has four different tasks, and I'm going to walk you through step by step. And you can apply this method for anything. By the way, if you want to create your chatbot in a very specific domain, you can just use this method. But just keep in mind that if you use that, you'd need a good computational power, because you need to fine-tune a GPT or any other big LLM. So you're going to need a GPU. But this method is a great way to create your own domain-based chatbot. So the first step is the data collection. So before conducting an ML tasks with the language model, a data set of human-generated prompts and responses is compiled for training purposes. These prompts and responses serve as the training data for the model. And this data should be based on your domain. I know if you work in a health company, those data must be about what you give to customers. So this will going to be your knowledge base, actually. A knowledgeable individual within the organization provides accurate and natural responses to this prompt. So as you can see here, I just gave 3 data. How can I talk to customer services? How can I pay my invoice? How does the subscription process proceed? And every question will have their appropriate answers. This will be your data. And the second part is the supervised fine-tuning of the language model. So a commercial pre-trained model serves as the base for further refinement. So this model can be any model. I use GPT again, but it might be any internal model in your company, or any internal model that you trained before, or it might be like Llama, Mixel AI, or Falcon, maybe. And the techniques like retrieval, augmented generation are utilized to fine-tune the model according to the company's internal knowledge base. So this is your knowledge base, the data you collected in the first step, and then you're going to fine-tune the LLM GPT model with your knowledge base. During this process, the model's responses to predefined prompts are compared against the human responses gathered in the first step, and with mathematical algorithms calculated the similarity between the machine-generated and human responses. So for instance, machine-generated responses are assigned a score between 0 and 1, indicating accuracy, with 1 being the most accurate, like most human answer. These scores help shape the model's policy towards generating responses closer to human-like accuracy, forming the foundation for its decision-making process. So you fine-tune your LM model with your knowledge base. So you give the information about your brand, about your domain to GPT. So you'll have a GPT with knowledge of your data, and then you're going to ask any question in your knowledge base to fine-tune GPT model. And then when you get the response, you will use a similarity model just to have an idea, like what is going on with your fine-tune model. So you just calculate the similarity score with the real answer, human answer to that same question, same prompt. So you just analyze, like evaluate your fine-tune GPT. The third part is building a separate reward model. Reinforcement learning with human feedback involves training a separate AI reward model based on human feedback. I think this is the best part. This model serves as a reward function for optimizing the policy through reinforcement learning. Multiple responses from the model to the same prompt are presented to humans for rating based on quality preferences. These preferences inform the construction of the reward model. So estimates how favorably a human will score a given responses to a prompt. Shortly, like we give, this is our fine-tuned GPT model from here. This GPT model has a knowledge base. It has our knowledge base trained, and if we give any prompt, then we use in our knowledge base, and then we ask the same prompt several times. In this case, we asked it like 3 times, and each question with each prompt, we're going to have different responses. So we're going to give those responses to humans, and we're going to expect them to score this responses, like how human and how good those answers are. Like, if I would like to get those answers to myself from a chatbot. So they just rate that. And then we will have responses and scores. So we're going to fine tune another LM model. Again, this might be GPT or Llama, another model, or even your language model. So you're going to, again, fine tune that model, and you're going to have your reward model. In the fourth part, you're going to optimize the language model with the first two models that you trained. So at first, we just collected our knowledge base, and then we trained GPT. We fine-tuned the GPT model with our knowledge base, and then we asked the same question for a couple of times, and then we gave those answers to a human and get the score from them, and then we fine-tuned another base LLM, and we had the reward model. And then right now, like ChatGPT does, but they all say, OpenAI always say that ChatGPT might have toxic content in the responses, might even give you the wrong content in the answer, or their behavior in the response might not even right. They trying to add policies to their model to restrict those answers, and they made it happen like this. So they give a prompt to fine-tune LLM, and then you get the answer, and before return this answer to the prompt, you give this answer to your reward model. So if your reward model says that this answer is appropriate, is an answer that a human might expect from a chatbot, then this answer return to the human as an answer. But if the score is really low, then you just return the question back to LM, fine-tune LM, and get another answer, and you do that all over again. So this was the method, and I think that method is really, really great. And I will give you more links about that so you can read more. But now we understand a little more what GPT can do and how GPT do that. We have a model with advanced communication skills, while that deficiency that I mentioned in the first part of the presentation has now become minor. We can turn it into an advantage for our chatbots because our models now can understand the meaning of a word. You can do most of the things that I will mention here with the LangChain framework. LangChain is generally used in development with LLMs. We use most of the terms that I will use after this part of the presentation in the developments we make on LangChain. I just mentioned that we can fine-tune a language model such as a GPT with something called knowledge base. I would like to explain the term knowledge base a little more. GPT is a model trained with a lot of data, yes, but the purpose of chatbots is to serve a certain domain. In other words, if company X is a telecommunications company, the question from its customers will be related to this issue. In this case, a chatbot you create with GPT infrastructure will be no different from another ChatGPT. You will want a chatbot that acts as if it's your company's assistant, answering questions only about your domain. On the other hand, it will not be possible for the information about your domain to be in the GPT training set. In this case, it is necessary to export external data to GPT. This data is called knowledge base. You will need to put this knowledge base into a database called vector database. Vector databases are places that allow you to store your data as expected by language models. After loading your knowledge base from the source you want, you will need to give this information to the embedding model of the language model you will use and get the embedding outputs. The reason I put OpenAI embedding here is that I continue with the GPT example. You will now be able to transfer your numerical data after embedding model as vectors to the vector database. Knowledge base can be anything. All papers in the archive frequently ask questions of a brand, etc. But you may want to personalize your chatbot even more. Or you may want your chatbot to access up-to-date data. You may want your chatbot to access to internet. But you may not always want to do this. This is another chatbot structure, actually. So LangChain includes everything you need to create your agent. What makes an agent good are its tools. These tools determine which resource should be visited and under what conditions this service should be visited. LangChain has many built-in tools depending on the needs of your project. You can go to services such as Wikipedia, archive, internet. Likewise, you can create your own tools. For example, you can create your own tool with a service that contains information that you can provide. Depending on the situation, you may have more than one tool. The most important thing that distinguishes these tools is the descriptions. This explanation is the area where the structure you created with your language model will decide where to look with the incoming question. By the way, this is valid for custom tools. If you are going to make a chatbot suitable for your needs, it is quite likely that the tools you will use will be the services you will provide. So you'll get a query, and those queries will make a semantic search with the descriptions, will decide which tool to use, and then if they choose the tool 2 is a way to find the answer. So you will use the tool 2 to get the answer, and then agent will return your response. And in the last second slides, we're going to talk about prompt. GPT is a big model, a huge model. It may not be wrong to assume that it has knowledge about many subjects. If you ask ChatGPT who it is right now, it will tell you that it's a language model developed by OpenAI. This is one of the other situations that will not be beneficial for your own brand or domain. Therefore, so that GPT can be used by more people or companies, you can type prompt and use GPT with the identity you want. This prompt is a field where you can write what you want GPT to be and represent. In addition, it is an area where you can specify rules, such as how to behave in which situations and what to avoid. You can make GPT easier to understand by adding examples to it. Like in here, I wanted my GPT to be a helpful teacher, and a helpful teacher that only answers questions about math. So if you ask a question about sciences, probably it will say that it doesn't have any idea about that. But normal GPT, if you'd ask a ChatGPT about a health question, it will answer. But for my GPT, I just limited its abilities as through the math questions. And lastly, let's take a look at what we've learned. Here is a question from a user. With this question, first of all, it goes to the knowledge base, sees if there is any similar information, and then it goes to LM with the information it gets from there. LM, on the other hand, creates an answer to be given with the information it receives and returns it to the user. LLM here can be any LLM model you want. It can be a fine-tuned version, like I just show you, or its own version, a version that you can use with your chatbot. And that being said, it was my presentation. Thank you for listening. If you have any question, you can always contact me.
Thank you for your presentation, Deniz, and we can get questions from the audience. Either you can unmute your microphone, ask your question, or you can post your question in the chat.
Can I ask a question?
Yeah, sure.
Okay. Thank you very much for your nice presentation. Were you able to practice some of these techniques in certain projects? And what were the difficulties? So, did you have a need to apply a couple of them in order to get a better performance? And which verticals do you think are more problematic, so on and so forth? If you have, if you want to share any kind of your know-how. Thank you.
Yeah, thanks so much. Actually, I experienced this. I used these methods in a project. And actually, to be honest, I'm using these methods in my own professional life. And I had a project like this in my GitHub page. And actually, I used every method that I just showed you in this repository. So you can just feel free to check out. And there's an article about that in Medium. I can just send you the link if you want. The most difficult part, I think, is the always data part. Even in the knowledge base, that you have to, like I told you, back then they have to think about every chat scenarios to create patterns. So I think even now, when you create knowledge base, it's so important to think about every angle, because a customer can ask you any question about your brand. So you have to collect your data very carefully. So even though you have a large language model, you always need to have a proper data for your problem. And because, like I said, GPT is a very big model. It's trained on very big data on the internet, but it's likely that it doesn't know anything about your data. So I think the hard part is to create your own knowledge base. And there are some methods to do that. So in that actual repository, I show the way how you can do that. So you just feel free to check out, like I said. Other than that, I think prompt part is hard too, because sometimes GPT doesn't understand or doesn't want to understand what you just wrote down in prompt. It just do whatever it wants to do. So I think tweaking prompt might be hard too. And other than that, with agents, I think agent part is a very unique part in this field, because if you look at the documentations about agents, there are not much documentations about that. Even if and if you use Python as a language, programming language, it's more hard to find knowledge documentation about agents. So agent part must be really hard, like I said, because there's not much development there. So you might get a hard time to find the right solution for yourself for the agent part. So every part has their own exact difficulties, but it's not something that you cannot make it for like every project that you can manage it. But it's going to be sweet, because like creating chatbots that answers your domain is such a good joy, because when you ask a chatbot anything you want it to answer and it gives you the right answer, it's a great feeling. So that was the answer. I hope it helped. I think there's one more question in the chat.
We can get one more question, and that will be it.
Okay. Oh, there are a lot of questions. Okay, let me just read. Okay, for this guy's question, like I said in the presentation, there are some policy ways, like reinforcement learning by human feedbacks. Those methods are preventing other people to get sensitive information through prompt. So you might fine-tune your policy model, reward model more carefully. And other than that, actually, I have not much knowledge about that. But like I said, with the method I just told you about, reinforcement learning with human feedback, is a really great way to add policies to your model. So you just maybe add one layer of policy. Maybe you can add just 3 layers of policy according what you will give with those with that ChatGPT, with that chatbot actually. So you might just maybe you can just use that reward model 3 times in your ChatGPT chatbot. Although I don't have any more information about prompt engineering, so this is all I can give you as an answer. Mariam, for your question, this is actually what agents does. So all you have to do is you're creating an agent, and you give that agent a ability to connect your database if when needed, and then answering the query, the prompt of the user, and answer it according to the database. Actually, this is what agents does. So all you have to do, like I said, just let GPT to access the database, and then it will return the answer according to that database. For Behzat's question, does it include semantic search? If yes, as far as I know, GPT does its own search in knowledge base. It has its own search algorithm to get the, I think, first, like you can choose that, I think, for same or high score questions, answers in your database or knowledge base, and then just use it as an answer. And vector embedding, like I said, what model do you use, and then use that vector embedding. If you use GPT, you'll use OpenAI embedding actually. If Llama uses a different embedding, then you're going to use a different embedding model, and those embeddings you can find them on the LangChain's documentation. Actually, there's nothing you can do with token limits. So we don't do much about token limits. You're being charged with every token that you send and you get from GPT. So there's nothing that I do actually. For Canberk.
We have 1 more minute remaining.
Okay, the last question for Canberk's question. Okay, this is a question about the, I think, legal part of this part of the companies, but with OpenAI giving you an opportunity to actually manage that. So you can just reach out to OpenAI, that you can say that we're going to use that in our business, and they just making the right arrangements about that. But like I said, this is not something that I do. This is the legal part of the situation. I think it's done. Okay, if you have any question, you can just contact me after this. Thank you for listening.
Have you shared your contact information, maybe in the chat?
Okay.
You can post your accounts.
And
in the meanwhile, I can make an announcement for our next speaker. The next speaker is Reshmi Ghosh from Microsoft US office. And to Canberk's question, she's going to have a presentation on AI safety and LLM safety. So we will have a dedicated presentation for that. And please stick around for our next guest. We will start in 9 minutes.
Okay. I shared my LinkedIn and Twitter accounts. I use those accounts mostly with technical stuff, so you can just contact me with these two social media platforms. Okay, thank you for inviting me, Onur.
Thank you. See you all in 9 minutes.